Good day. Today I'm going to show you the understanding of trigonometric graphs and also how to deal with some questions. And we're also going to deal with amplitude, range, period, and endpoints. If you want more examples on trig graphs and if you want to learn trig graphs from the basics to the higher level, the playlist is found at the end of this video. So, let's begin. First of all, this thing is very important to memorize. You should know this by head. Just like you know the standard form of a parabola, how that a parabola is ax squared plus bx plus c. So the same way you know the standard form of a parabola is the same way you should know the standard form of a trigonometric graph. So to be good in functions, you have to know the standard form of each type of functions and what each parameters affect. So in this case, you have to know what a affects, what k affects, what p affects, and what q affects. So this has to be crammed. Before we talk about what the perimeters affect, let's talk about the difference between the sine graph and the cos graph. Let's start by drawing the sine graph. So y is equals to sine x. So this is the normal sine graph. So the sine graph usually starts from the origin. It usually starts from point 0 to 0. The sine graph always has this S shape. The cos graph, on the other hand, is just like the sine graph. It's just that the sine graph is 90 degrees ahead of the cos graph. Notice, if I shift the red graph 90 degrees behind, they will just mix. So the two graphs will just become one graph. So the sine graph and the cos graph are exactly the same graph. It's just that the sine graph is 90 degrees ahead of the cos graph. Notice, with the cos graph, the highest point is at the y-axis, while with the sine graph, the highest point is 90 degrees ahead. So the normal sine graph is 90 degrees ahead of the normal cos graph. So this is going to be very important. Always remember that the normal sine graph always starts from the origin. We're going to talk about what the perimeters affect, but before that, let's also talk about the tan graph. This is how the tan graph looks like. The tan graph is different from the other two trigonometric ratios. The tan graph has this S shape. The tan graph has asymptotes in intervals of 90s and 270s. It is error which represents asymptotes at intervals of 90s and 270s. This is for the normal tan graph. This won't always be the case. At times, asymptotes are found at different places depending on the perimeters. By the way, the normal tan graph also starts from the origin. When we don't add any perimeters, the normal tan graph will start from the origin. Let's talk about finding the period of the tan graph. Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEB, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvements. So, how do we get the period of the tan graph? Notice, in other graphs, the period is the length of one complete wave. So it's the distance, the length of one complete wave. What about with the tan graph? It's the same thing. It's just that this is one complete wave. So how do we get the distance? We just have to say the value of one asymptote minus the value of the other asymptote. So in this particular case, for instance, we have 90 minus negative 90. So 90 minus negative 90. That gives us 180. So it tells us that the period of the normal tan graph is 180. So that is how it is. So we get the period by using any two asymptotes that are close to each other. For instance, we can also use 270 and 90. We can even use this value and this value. Negative 90 minus negative 270, which will end up being negative 90 plus 270, which will also be 180. The same way you have memorized for sine and cos, you also memorize the same for tan. It's just y is equals to a tan k. So we're going to have k. Some students use b. It's up to you. X minus p plus q. So the same as for sine and cos. Now let's talk about what each perimeter A, P, K, and Q affects. So this is the normal sine graph. In this case, the value of A is 1. We are going to double A and we're going to see what will happen when we double A. But before we double A, if you're interested in knowing the prices of my tutorials, the video of the prices is found at the end of this video. So what about if we double A? Because remember, A is what is in front of sine. Here in this case, A is actually 1 because when there is nothing, there is actually an invisible 1. Because if it was 0, it would be 0 times sine x, and the whole thing would just disappear and just leave 0. So the minute we see that sine is there, it means that there is a 1 in front, so A is 1. So whenever A is 1, it means the lowest point is -1 and the highest point is 1. Notice the lowest point is -1. So lowest point is -1, the highest point is 1. That is why in a trigonometric graph, whenever you try to type, you want to find out which angle can give you, let's say which angle can give you 2. So if you type arc sine 2, if you type inverse sine 2, it will give you error. It gives you error because the range is always from -1 and 1, meaning that the values have to be between -1 and 1. If the value is bigger than 1 or lower than -1, then it's going to be an error, because the values strictly range from -1 to 1. So what about if we make A2? If we make A2, this is how the graph looks like. So this is how the graph will look like if we make A to be 2. So notice how that the amplitude has just doubled. So the graph became twice as wider in the vertical direction. So instead of starting at -1 and ending at 1, it now starts at -2 and it ends at 2. What about if we make A to be a half? Let's just say we decide to make A to be a half. So this is how it's going to look like if the amplitude is half. Notice the lowest part is -half and the highest part is half. So it ranges from -half to half. So this is what A affects. A affects the vertical stretch. So let's talk about Q. So before we talk about Q, let's look at the normal sine graph again. So as you can see, it ranges from -1 to 1. So Q represents the vertical shift. For instance, if we add 1 here, this is what's going to happen. This is how it's going to look like if you make Q to be 1. So there's going to be a vertical shift. So notice, instead of the lowest point being at -1 and the highest point being at 1, the lowest point is now at 0 and the highest point is at 2. So what happened to the graph is that it shifted 1 unit up. So therefore Q determines the vertical shift. So now we've talked about Q, let's talk about P. Let's take a look at the original graph once more. So let's say we want to draw a new graph. Let's say we want to draw a graph y is equals to sine x minus 90. This affects the horizontal shift. This is how the graph of y is equals to sine 90 minus x will look like. The green graph. Notice the green graph looks exactly the same as the red graph. It's just that the green graph is 90 degrees ahead of the red graph. Notice in the red graph the highest point was at 90. In the green graph the highest point is at 180. So it is just 90 degrees ahead of the red graph. So P affects the horizontal shift. The weird thing about it is that when you see a minus 90, it will shift 90 degrees to the right instead of the left. If you see plus 90, it means that the graph will shift 90 degrees to the left instead of to the right. So it's kind of like an opposite effect. So P represents the horizontal shift but in the opposite direction. For instance, if you have sine x minus 30, the graph will be exactly the same as the normal graph. It's just that it's going to be shifted 30 units to the right. If you see sine x plus 30, it means this graph will look exactly the same as this graph, but it will be shifted 30 units to the left. So the directions are the opposite of the signs that you see here. So we have talked about P. Let's talk about K. So before we talk about K, let's just cover things like endpoint. So what are endpoints? When they talk about endpoint, they're just talking about the left end of the point and the right end of the point. So They're talking about the beginning coordinate and the end coordinate. So what is the beginning coordinate? This coordinate, as you can see, is 360 is to 0. So the x value is 360 and the y value is 0. For the end part of it, the x value is 360 and the y value is 0. So these are the end points. They're just talking about your beginning point and your end point. Your beginning coordinate and your end coordinate. So that's just what I'm talking about. And let's talk about range. Range are all the y values from the lowest point to the highest point. So in this case, you will say y is an element of. When it comes to range of a trigonometric graph, you'll always be drawing square brackets, except for the range of the tan graph. So it starts from -1 and it ends at 1. Make sure you start from the lowest point and end at the highest point. Don't write 1 and -1. It will be wrong. So the graph ranges from -1 to 1. And let's talk about amplitude. In physics, if these are waves, you will actually know that amplitude is maximum disturbance. Maximum disturbance from the 0 point. So it's the maximum disturbance from the middle of the wave. So this height is the amplitude. So if you notice, the amplitude is 1. If you do not have the graph, the value of A actually gives us the amplitude. So in this case, there is nothing in front of sine, so we know that it's 1. It tells us the amplitude is 1, just like we can see in the actual graph. So amplitude is maximum disturbance from the middle of the wave. In other words, if we had a graph y is equals to 2 sine x, it will be doubled. So notice now the amplitude is 2. So this tells us the amplitude. The only thing you have to be careful of is that if this is a negative value, it doesn't mean the amplitude is negative. Amplitude is distance, and distance can never be negative. So amplitude will always be positive. So if you have a graph y is equals to -3 cos x, for instance, it means that the amplitude is 3 and not -3. So the amplitude is the maximum disturbance from equilibrium, which is the middle point of the waves. So we have talked about A, we have talked about P, we have talked about Q. Now let's talk about K. What does K affect? So notice, A affects the vertical stretch, but K will affect the horizontal stretch. So it affects the horizontal stretch. For instance, let's manipulate the original graph and let's see what's going to happen if we put 2 in front of x. So if we put 2 in front of x, this is what we're going to have. So this is the graph of y is equals to sine 2x. So notice, the weird part about it is that we put 2, but it didn't become 2 times wider. It instead became 2 times thinner. So this affects the wideness in the opposite direction. So the part that is going to be important about K is the period. So let's talk about period. The period of the graph is the length of one complete wave. That is the period of the graph. So the period is the length of one complete wave. In the sine graph and in the cos graph, it is usually 360, but in the tan graph, it is 180. We'll talk about the tan graph in a moment. So whenever you want to find the period of a graph, let's just say you are given this equation and you want to find the period of the graph. The period of a graph is always equals to 360 over k for the sine graph and for the cos graph. We will talk about the tan graph in a moment. So k is just this value. Remember, we memorized the fact that y is equals to a sine k x minus p plus q. So k is just this value. Some students call it b, some students call it k. I just prefer calling it k. So if you want to find the period of the graph without looking at the graph, we can just simply use the equation. So the period of the graph will be equals to 360 over k, in this case is 1 over 2. And because of this effect, we'll have period is equals to 720. So the period of this specific graph is 720, meaning the length of one complete wave will be 720. So just remember, K has the opposite effect. If you see 2, instead of the graph being doubled, instead of the whiteness being doubled, it will rather be halved. They are smaller in terms of width, but not in terms of height. So we know that instead of this one being halved, it's going to be doubled. So let's draw this graph. Notice when K is half, the whiteness of the graph actually doubles instead of being halved. And the period of the graph, if we look at this length, is actually 720 because it's actually 360 minus negative 360, which actually gives you 720. So the period has been doubled. Usually it's supposed to be 360, but it became 720. So when K is halved, the period actually doubles instead of being halved. When K is 2, the period actually halves instead of being doubled. So we have dealt with A, we have dealt with P, we have dealt with Q, we have dealt with K. Let's just deal briefly with how to answer some questions. And the advanced part will actually be in the next video, which is in the playlist. Alright, this is the beginning of how to answer the questions. These 4 questions are important in past papers. The value of A is just the basic to a question that will be important in past papers. So when they ask for the value of A, they're just talking about the coefficient of sine. So we've memorized that y is equals to A sine K into x minus P plus Q. So A is just this part. So in other words, A is negative 2. So A is negative 2. So sometimes they can give it to you in a graphical form. Then they don't give you the value of A. And they ask you the value of A. If they ask you for the value of A, you just have to check what is the minimum and maximum value. So the minimum value is minus 2 and the maximum value is 2. It means that the amplitude is 2. You must just make sure they are evenly distributed. Make sure if it is a 2, this side must be at minus 2. Or if it is a 3, it must be at minus 3. We'll talk about what to do if they are not evenly distributed. So the amplitude is 2, meaning that A is supposed to be 2. But notice, it starts with the minimum before maximum. Whenever the graph starts with minimum, I'm talking about immediately after the y-axis. So from the y-axis, you have to check what comes first. Is it the maximum or is it the minimum? Whenever the minimum comes first before the maximum, the value of A will be negative. So in this case, because the minimum comes first before the maximum, the value of A is negative. So if we had a graph like this, let's just say we had a graph like this, and we had something like, let's just say we had a graph like this. Notice the maximum value comes first before the minimum, meaning the value of A is positive. What about if we had a graph like this? So if we had a graph like this, notice from the y-axis, we have immediately the maximum first before minimum. So we have to check, just as long as it's not before, we have to check from the y-axis which one comes first. Is it the maximum or the minimum? So in the first case, from the y-axis, we did not have either the maximum or the minimum yet. But afterwards, we have the minimum appearing first before the maximum. So what about if we have a graph that is drawn this way? If we have a graph that is drawn this way, notice from the y-axis, we immediately have got the minimum appearing. So from the y-axis, the minimum appears first before the maximum. So make sure you check exactly from the y-axis which one will appear first. Is it the maximum or the minimum? And then from there, you're able to tell whether A is positive or negative. So if the minimum comes first before the maximum, A is negative. But if the maximum comes first before the minimum, A is positive. So this method works whether it's sine or cos or tan. So just from the equation, we can see that A is negative 2. Then they ask for the amplitude. If they ask for the amplitude, even though A is negative 2, the amplitude is not negative 2. The amplitude is 2. Because amplitude is distance, and distance can never be negative. So the amplitude is 2. You just have to be careful of something. Since we have a graph that is drawn this way, we can clearly see that since it starts from -1 and it ends at 1, we can tell that the amplitude is 1. Immediately from the y-axis, it starts with the minimum first before the maximum, so we can tell that a is negative. And therefore, since the amplitude is 1, it means that the value of a is -1 because it starts from the minimum before the maximum. So it is easy to see the value of a and the amplitude whenever it's evenly distributed, whenever the negative and positive values are the same. In this case, we've got -1 and we've got 1. But in this case, it is not as easy to tell the amplitude. The major mistakes that most people make is actually to see that it ends at 2, or rather that the highest point is 2, and they say the amplitude is 2, but it's not true because it's not evenly distributed. The amplitude is the maximum disturbance from the equilibrium, which is the center of the wave. So that is the amplitude, the maximum disturbance from the center of the wave. So whenever they are not evenly distributed, for instance, here in this case, the lowest value is 0 and the highest value is 2. So the range is from 0 until 2. So because the range is from 0 until 2, it means they're not evenly distributed. If it was evenly distributed, it was supposed to be something like the range from -1 to 1, or the range from -2 to 2. So it's supposed to be something like this. The numbers are supposed to be the same. But because the numbers are not the same, it means that it's not evenly distributed about the x-axis. So whenever the numbers are not the same, you do not take this as your amplitude. Your amplitude is not 2. So how do you find your amplitude whenever they are not evenly distributed? What you'll do is that you'll set the highest value minus the lowest value divided by 2. So in this case, it's just going to be 2 minus 0 divided by 2. And it means that the amplitude is 1. Another example, let's just say its range is from -1 until 3. For you to find the amplitude, you will just say the highest value, which is 3, minus the lowest value, which is -1, divided by 2. And this part gives you 4 divided by 2 is 2. So it means the amplitude is 2 and not 3, as we can see, and not even -1. The last example, let's just say we've got a graph and it ranges from -5 until 1. So how do we find the amplitude? We take the highest value, which is 1, minus the lowest value, which is -5. So minus the lowest value, which is -5. And then we divide it by 2 because the amplitude is always half of the total distance. And this is going to be 6 divided by 2, which is 3. So it means the amplitude is 3. So in this case, the amplitude is 1 because we said the highest point, which was 2, minus the lowest point, which was 0. And because the amplitude is half of the total length, we have to divide by 2. And that gives us 1. So the amplitude is 1. But let's be careful. What about A, the actual A? If they ask for A, we have to check. Does it start with the maximum or the minimum? So from the y-axis, what comes first? What comes first is actually the maximum before the minimum. So it means that it's positive. So therefore A is also positive. So A is the exact same as the amplitude in this case. So the value of A is -2 and the amplitude is 2 because the amplitude is the positive value. Some students know it as the absolute value. What about the range? From the equation, we can be able to see the range because this tells us the amplitude. And since the amplitude is 2, it means that the lowest value is -2 and the highest value is 2. So just from this, we can tell where it starts and where it ends. There is something else that affects it. I'll show you that in the next example. So just by looking at this, we can tell our range. So our range is y is an element. So it starts from -2 and it ends at 2. So what about our shift? When it's talking about shift, it's talking about our horizontal and our vertical shift. So P and Q tells us our horizontal and our vertical shift. In this case, we have got Q as 0. We're not given the value of Q, so therefore Q is 0. What about P? P tells us the horizontal movement. So because it's negative 30, it means it moves 30 degrees. So it moves 30 degrees to the right instead of the left because of the opposite effect. If it's negative, it moves to the right. But if it's positive, it moves to the left. Now let's talk about the period. This part is very important. So how do we get the period? In order to get the period, we know that period is equals to 360 over k. That is for sine and for cos. But for tan, period is equals to 180 over k. But because we're dealing with the sine graph is 360 over k. So let's find out what is the value of k. So the value of k is 2. So it means it's 360. So therefore period is going to be 360 over 2, meaning that the period is 180 degrees. So we have found the period. And there we have it. We have answered all these questions pertaining to this equation. Alright, here is another example. So you are given y is equals to negative sine x plus 90 minus 1. So what is the value of a? The value of a is negative 1. They can matter of fact give you this in a graphical form. So this is how it's going to look like in graphical form. So how do we tell the value of a? We first have to get the amplitude. Now the amplitude is the total distance divided by 2. So it starts from 0 and it ends at 2. The lowest point is at 0, the highest point is at 2. So it means we have to say the highest point minus the lowest point divided by 2 because it's half of the total distance, the total vertical distance. So it's 2 minus 0 divided by 2. And this gives us 1. So we're not yet done. We have found the amplitude, but what about a? So we have to find out, is it positive or negative? So notice from the y-axis, what comes first is the minimum. So it's the minimum before the maximum, meaning that a is negative. So it means that a is negative 1. So a always tells us the amplitude. The only difference can be the sign. So if they give it to you in the form of the equation, we already know that a is negative 1. So what about the amplitude? Since a is negative 1, the amplitude is the same as a, but the amplitude is always the positive value because it's distance. And by the way, the graph that I gave you is not exactly the same as this stuff. I'm just showing you an example of a graphical equation that they can give you. So let's say they ask you for the range. If they ask you for the range, so let's find the range. By looking at the coefficient of sine, we can say that the amplitude is 1. So it means that the graph is supposed to start at negative 1 and it's supposed to end at 1. But we've got a slight problem. There is a shift. This is also the other thing that affects the range. So it means that it shifts 1 unit down. So if it shifts 1 unit down, it means the whole graph will shift 1 unit down, meaning that this, instead of it being 1, it's gonna be at 0. And this one, instead of being at negative 1, it's gonna be at negative 2. So it shifts 1 unit down. So it means that this is our new range. So therefore our range is y is an element of, it starts at negative 2. Remember, we have to start with the minimum first before the maximum. So it starts at negative 2, it ends at 0. And there we have it. We have got the range. So what about the shift? Well, this time we've got P and Q. So P is 90. So in this case, it means that the shift is 90 degrees to the left. It has to be the opposite. So it's 90 degrees to the left. So if you say plus, it's to the left. If you say minus, it's to the right. So it's 90 degrees to the left and 1 unit down. So what about the period? Well, let's look for the value of k. The value of k is not given, meaning that it's 1. So it means we're going to say period is equals to 360 over k, and k is 1, so it's 360 over 1, and the period is 360. But we don't necessarily have to show them this equation. Whenever there is nothing in front, they will just say write down the period and it's going to be 1 mark. So you don't have to show the calculation, you already know it's 360. So whenever there is nothing in front, meaning that there is a 1, we know that the period is 360. That's for sine and cos. But if it is tan, we know that the period is 180. Alright, this time we're given a tan graph. So they ask you for the value of A. So what is the value of A? Well, the value of A, we can see it is -2. So A is equals to -2. What about the amplitude? Even though we've got the value of A, the amplitude of a tan graph is undefined. So this is how the tan graph looks like. Now notice, it begins from -infinity, there is no lowest point, and it also ends at -infinity, the highest point. So if they ask for the amplitude of a tan graph, the amplitude is a distance. We can't say the distance is infinity. So the amplitude of a tan graph is undefined. So the amplitude of a tan graph, you always have to remember, whenever you see tan, the amplitude of a tan graph is undefined. It doesn't mean we can't find A. There is always A, but there is no amplitude for the tan graph. We can also find the range of a tan graph. So the range exists, but the amplitude does not exist. So the range exists because it's where it starts, where it ends. So it starts from -infinity, it ends at infinity. So the range of a tan graph, you will always say y is an element of -infinity to infinity. You'll always say that. So that is for the tan graph. So infinity always has a curved bracket, whether in paper 1 or in paper 2. So this is the case where you'll put curved brackets. It is when we talk about the range of a tan graph, it will always be curved bracket, and it will always be -infinity to infinity. So whenever you see tan graph, it is always -infinity to infinity when they ask for the range. What about the shift? Well, the shift is the same. In this case, we have got the shift, which is 90 degrees to the left and 1 unit down. So the shift is 90 degrees to the left and 1 unit down. So 90 left, 1 unit down. So let's talk about the period of the tan graph. Well, the period of the tan graph, we know that period is equals to 180 over k. And in this case, our k is 1. So we already know that the period is 180. We don't need to show the formula or the calculation. But if k was not 1, you will just write down the value. So you write down the value of k and you will get your period. So in this case, period is 180. And this brings us to the end of the video. So tune in for part 2, which I have included in the playlist of Trig graphs. If you enjoyed this video, please like the video and subscribe to my channel. Any questions or any video you want me to make, please comment below.